So we are going to look at the inverse trig functions. Before we start, let's talk about what an inverse function is. If you remember from like an Algebra 2 class or something, an inverse function is one that switches the input and output. You start with x, and then normally a function you put in x and you get y. Well, inverse you put in y, you get x. If we think about a trig function, like our trig functions, we could say like sine of 30 degrees is, look at unit circle, use the y value is 1/2. So if I did the inverse of sine, then I would start with 1/2 and I would get back 30. And so that's the first thing to kind of make note of, or you could say pi over 6, is the inverse will give you an angle. So if you remember something from this video, make sure you remember that the inverse gives an angle. Okay, and then the other thing with inverse functions is for a function to have an inverse, it had to pass the horizontal line test. Well, if we think about our sine graph does not pass the horizontal line test. So if you saw this graph in Algebra 2, you would say, well, this graph does not have an inverse. And so what are we going to do? We can't find sine inverse. Well, we just said, well, let's only look at part of the graph. Let's take away everything except for like this part right here. And so if I only drew just a little part of the sine graph, if I only drew, we'll say this part right here, then it does pass the horizontal line test. And that's kind of confusing, but the outcome of that is this column, which is very important. So the outcome of that is when we're finding or evaluating inverse trig functions, we can only look in certain quadrants for angles. So the inverse sine will never give you an angle over in these quadrants, in quadrants 3 or 4. The answer will always be in quadrants 1 and 2. And so let's go through this very briefly, and then we'll use them in the other, in some example problems. And so for sine in between negative pi over 2 and, in between negative pi over 2 and pi over 2, that's from down here all the way up here. So sine, a quick way to remember that is quadrant 1 and quadrant 4. However, a confusing thing about that is that sine is not allowed to be 11 pi over 6, 7 pi over 4, or 5 pi over 3, or maybe 300, 315, 330 degrees, because it can't be bigger than 90 degrees. So you got to think about these values as their coterminal angles, or the negative version of them, which would be like negative pi over 6. This one would be negative pi over 4. And this is negative pi over 3. And then those fit in this range rule. For cosine, we're going to have angles in between 0 and pi, so that's just in the first two quadrants. So quadrants 1 and 2. And the reciprocals for these will follow the same rules. So for cosecant is in 1 and 4, just like sine. And you'll still have to use the negative angles. Secant is in 1 and 2, just like cosine. And then tangent and cotangent are the kind of goofy ones. So tangent, remember, is sine over cosine. And so it's going to go with sine. It's going to have angles in quadrant 1 and quadrant 4. And then cotangent is cosine over sine. And it's going to go with cosine. So it's going to have quadrant 1 and quadrant 2. You have to memorize these right here. These need to be memorized for each trig function. Because almost every problem you'll do with, well, every problem you evaluate inverse functions, you need to do it, and then we'll solve some angle or solve some equations, and you'll use it there as well. So you have to have those values memorized. Okay, let's look at a few examples here for some practice. Whoops, I don't want to do that. So cosine inverse of square root of 2 over 2. So what we know about cosine is the x value on the unit circle. And so we're looking for an x value that is square root of 2 over 2. Specifically, we're looking in quadrants 1 and 2 because I want my angles to be in between 0 and pi. So in quadrants 1 and 2, I have an x value square root of 2 over 2 right here. And so let's evaluate these in radians. That means my angle is pi over 4. And so we are using the unit circle just in reverse order. And that's it. That's the only step there. Let's look at sine inverse of negative square root of 3 over 2. So now we're looking at sine inverse. So I'm looking in these two quadrants. And I'm looking for where y, remember sine goes with the y coordinates, is negative square root of 3 over 2. And so you go through, proves that up, there's a negative square root of 3 over 2 right there for the y coordinate. So that means the angle that gives me this is negative pi over 3. If you say 5 pi over 3, that is incorrect. That's a coterminal angle, but it's not defined. Sine inverse is not defined there. You cannot go past pi over 2. Or if you were to say 300 degrees, that would be incorrect because you can't go bigger than 90. You have to go down in the negative angles to get negative 60 or negative pi over 3. And let's look at one more here. Number 3 is arc secant of negative square root of 2. And the reciprocals are kind of tough because you got to know your unit circle pretty well. But remember, we're going to flip the x coordinates to find secant, because secant goes with cosine. And we are looking in quadrants 1 and 2, so let's mark that on my circle. And I would suggest you write that down on your circle or mark it, or in the problem you could even say like just put like a little 1 and 2 there. Also, I would recommend you writing these values on your circle until you get in the habit of using them. So anyway, we're looking for where when I flip x I get negative square root of 2, and that occurs right here. And we'll go ahead and flip it for a little algebra review here. So if I flip this over, then I can rationalize, and my 2's will cancel. I got a negative, I'm losing. And so I get negative 2 square root of 2 over 2, which is negative square root of 2. And so there's my match. It is 3 pi over 4. And it could be 135 degrees. There's nothing wrong with that. To just decide if you want radians or degrees, you just have to pay attention to the directions. And so whatever, if it's not specified, probably default to radians. It's a little better used. But otherwise, just read the directions. And if it says use degree, use degrees. If it says use radians, use radians.